Hello, welcome to this session of CREO BMX. And today is a bit advanced section of CREO. As you can see, I have this simple mechanism. Let me rotate the simple mechanism, you can see. And the task of today is we are going to analyze this mechanism. As you can see, this body here, let me just rotate, has certain interference. You can see we have this interference here. Let me just hide this for ease of visibility. You can see some interference here between those two bodies. If I go to analysis, if I do pairs clearance and select component or body, if I select this and this, you'll see that highlighted volume of interference 47. And the task is to eliminate this clearance by setting a certain minimum gap between this face and this face. We need to determine the minimum gap. Maybe we want these two faces to always have a gap of something like 5. Let's say our goal is to set a gap of 5 mm between these two surfaces. Okay. Therefore, I'm going to hide some bodies here for ease of visibility, and let me just return that one. If I go back to the model here, if I drag this, let me just pull it there where I don't have interference. Let me just pull it, drag it a little bit outside. I already have this mechanism. If you want to know more about the mechanism, I already create a detailed video that will cover a lot of mechanism. This is the mechanism environment, and the mechanism I have analysis is called analysis definition 1 kinematics. And let me just move out from this analysis. And the first thing we need to do is to define this gap between these two bodies. What we do is you go to the global interference, do pairs clearance, and I want to pair. I can select component, this and this. You can see now we have a clearance of 50, but this clearance of 50 is not constant. It's not, yeah, it's a dynamic clearance because we are performing dynamic analysis. Hence, this clearance value will keep changing from positive to negative because of clearance. Okay. If I do saved, if I save this, I'll see okay. If I try to move this body until they interfere, let's see. If I go back to analysis, save the analysis, I'll double click this one here. We get the volume of interference because we can't get a negative value for the clearance. We can't say that. We just give volume of interference. Therefore, let me just go back on how it was. Therefore, if you go back again to analysis, save the analysis, you see this value is now is 23. It changed to another value. Therefore, this value of clearance, I'm going to save this value. Instead of saving it, let me perform another pairs clearance between those two bodies, this body and this body. Instead of saving, I'm going to do feature. I'm going to call it clearance 1. Okay, let me call it uh, clearance surfaces between two surfaces. Yeah. Okay, let me delete this, an existing one here, like that. Let me just delete that. Yeah. So let me just delete this one. These are some of the analysis I've done initially, and let's go to how it was. That okay. Now I have these clearance surfaces. If you want to see the value of this, just left click, go to information, feature information. I've just customized my my mouse here. include some of the values here. Therefore, just go here, feature information to see the value. The value is 22.9 millimeters. Okay, let's see. Therefore, if I go back to analysis, I'm going to perform what we call motion analysis. You can get motion analysis here, or you can go to analysis here, give it motion analysis, and call it separation, maybe distance, like that, and say next. When you do that, I need analysis definition 1. This is the name of our analysis. It is analysis definition 1. This mechanism analysis. If you have several analyses, you can select them here. And then the clearance surfaces is the pairs clearance, the one we measured here. Then if you want to perform collision, these are the just measure. If you want to perform collision detection, maybe you might ask yourself, where are these measures coming from? Let me just explain before I proceed. Yeah, let me just cancel. Yes. Let me go back to mechanism. These are this measure here. They are coming from here. Let me just delete them because I don't want you to get confused on where this is coming from. This one is the one we have just defined. Let me also delete it. Yeah. Okay, we can delete it. Okay. Because it is this one here. Clearance surfaces here. Clearance surfaces. Let me just do some two surfaces like that for ease of clarity. Clearance two surfaces. If you go back to mechanism measure, you can see clearance to surfaces. Therefore, we can delete this one here because this one we are getting it from the analysis tool here. When you go to analysis, global pairs clearance, that's how you are getting it. Therefore, I go back to motion analysis here. You can see. Also, I said you can get the same by going to analysis here, select motion analysis, but here you have to give it a name. You can say separation underscore two surfaces, like that. If you do next, you see now those two measures disappeared, but we have analysis definition, the name of our mechanism. Then I said we can also perform collision detection if you want. Perform collision detection so that the parts that are colliding or interfering, you can get feedback. You can have collision detection settings whereby you can say no collision detection, global collisions, or partial. Let me do this partial. I can say this and this. Give me a partial there. Partial collision. Just that. Don't do anything. Okay? I don't do anything. So just doing just that. Don't do anything. You can also create motion envelope. As this one is rotating, you want to see the surface, the volume that the rotating bodies are occupying by creating a motion envelope. I'll go into deeper details on to these ones here, but now let's focus on the goal of setting the minimum distance between those two surfaces. Therefore, I want to analyze. I can analyze collisions, but for me, I want to analyze this. Basically, let me just select everything and run. Let's see what happens here. Yeah, you can see we are getting this type of motion here. This one is a clearance. I can see the clearance value maximum is around this value here, but it reduces until it goes to the negative value. When you go to negative, it becomes volume. Okay, at this point is negative. We get a volume interference, hence we can't get this value. And for me, I want to get a value of 5. I'm looking for a value of 5 here. Okay, therefore, let me just close that. Let me see the results here. Results here. Okay, I can see collided parts. Yeah. Okay, close. Just close it. Let's see the results of this analysis. I don't need time. No, motion run time. I don't need it here. These are the results parameters. The analysis returns a result in form of a parameter. Corrosion detection, I don't need them for now. We are not performing corrosion analysis. Let me just scroll down here. My interest is the minimum value of parameter attained during motion. I want to get the minimum value. Yes, create this for me. Create this parameter and give it name minimum clearance and say okay. Therefore, in this analysis, if I go to the feature information, I should see minimum clearance. We are getting 0. Okay, because we are still getting a negative value, and it can't return a negative value because the type is a real number, has to return a positive value. Therefore, let's see how we can perform now the feasibility analysis to uh, to have to set that value to a specific number. Let's see how you go about it. I'm going to perform first sensitivity analysis, and I'm going to vary to move this direction. Therefore, the parameter I'm going to analyze is minimum clearance. Okay, by varying, let me see. Let me see this part here. A minute. I want to see this part here. Can see this dimension. This dimension I'm going to vary for extrude 2. Then go back to see feasibility dimension. This dimension here 2. We are going to vary maybe from 1 to 20 and do 20. Let's see options here. Okay, let's compute because I want to see how the feasibility will we just want to see sensitivity. What happens when that value of extrusion changes? We want to see what happens to the minimum clearance. That is what we call sensitivity analysis. As you can see, at 5 we start now around 4 we start getting a positive value, but uh, yeah, but 4 downwards we were getting a negative value. Yeah, it takes some time because it has to iterate, perform analysis, calculate the motion analysis, get the minimum value again. It has to iterate or 30. And I can see that if I can see my clearance increases linearly as the value of extrusion increases here. And for me, I want to scale down to 5. I want to see 5. Let me go to y-axis and scale from 0 to 10. I can go to y-axis here. Y-axis, cell up, user defined. Let's go to maximum of 10, 0, and 11 steps. Like that. Or let's see, 10 steps. Yeah, 10 steps. I can see now that 5, for me to get 5 here, minimum clearance of 5, the value is 10, but it might be 10 or 10 point something. Okay, therefore I'm going to change. We're going to determine this value. It is simpler here to get exact value from the graph, but assume you want something like 6. 6 might not be easy. In fact, let's do 6 because 6 might not be straightforward, or 5.5. Yeah, 5.5 is better. Yeah, 5.5 is around here. Yeah, you can see now you can't be able to estimate. It is between 10 to 12. Now I know for me to get a clearance of 10, 5.5, I have to get a value of between 10 and 12. With that information, I go back to feasibility, just close this one here. I perform what we call feasibility analysis. Is it feasible to set this clearance here? Let me show you. Set this clearance here to be 5.5, like that. Is it feasible to set it to be 5.5? Cancel. If I change the dimension of this extrusion here from 10 to 12, like that, to 12, and sometimes I don't know why it doesn't select here. Let me see. Okay, and if I'm going to have a convergence, this one means if I don't get 5.5, is it okay for me to get a value that is very close to 5.5, like 5.4? This is what we define here. I want it to be very accurate, therefore I'm going to give it a very small error margin. Maximum iterations is 50. I just leave it default, but most of time iterations don't exceed 4 most of time. If you want to animate model, you'll see the model changing as the analysis progresses. Also, I want to see constraints and variables. When I say I'm going to graph constraints and variables, and I say variables, this is a variable from 10 to 12. This you can see here, variables are the design variables. These are the dimensions that are changing from a certain value to another value. Right now is 10 to 12. These are called constraints, whereby we should not exceed 5.5. If you say okay, let's say compute and see what happens. It will give us some time to perform analysis, changes that value from 10 to 12 until we get the minimum clearance we need. Almost done. Performing the first iteration, you can see at the bottom, completing step 1 of optimization. Then most of the time it will do 2 steps depending on the complexity of your model and your design. Yeah, also it takes some time depending on the specs of your machine. Yeah, I'm going to pause video a little bit and come back when this one has run. After analysis, this one I got, no feasible solution has been found. Okay, when in case you get such feedback, you have now to go back to your minimum values here. Let me open up a little bit, maybe from 8 to 15. Then for the preferences here, convergence, let me just use maybe 0.1. Let's see, and compute. Let's see now if we're going to get a solution. Sometimes it's good to open up your convergence value. Yeah. Uh, I checked I checked back my analysis and realized we made a mistake here. We were supposed to use analysis, not clearance. Therefore, just delete this one here. Add, don't set this. Okay, you have to set minimum clearance, minimum. That's the reason why the model couldn't find the feasible solution, and you set that to 5.5, like that. Yeah. Uh, Select this minimum. It is the minimum we are focused on from the analysis we performed. Yeah, this one is the clearance to surface, the one we selected. But for the minimum, we are getting the value of minimum from the analysis. Therefore, if you go back here, we said it was from 10 to 12. Let's now run and see what happens. You set this to 5.5. Yeah, let's now see what happens. Cancel, compute. Now it should run very fast. I should have deleted this. I forgot to delete it. Yeah, on one model, just delete this one here. Okay, as you can see, my model has found a feasible solution. I modified a little bit. The minimum clearance I used 6. Then I open up variables from 0 to 20 because I know for 6 from the sensitivity analysis we found was 10. I said, let me just try 6. Then open up here. Then for the options here, the convergence I used 0.1%. But for the parameter, I used mean clearance. If I close this and confirm the new dimension, if I try now to go to model and rotate this one here, there's no crash. And if I try to check, let's do what we call motion analysis to see the minimum clearance now. If I go to analysis, motion analysis, let's run this motion and see. Yeah, you can see now the minimum is around 6. I don't know how you can select this value. Yeah, you can see we are getting 5.9635. That's what we are getting here. Also, if you perform your dynamic analysis, if I go to applications mechanism, if I go to measure, we can also graph. I can do a measure. I want to measure minimum position here. I want to see position. You can have a point like that and see also you can also determine the position of this point with respect to a coordinate system. You have to create a coordinate system here that will give you the same values. That is when you want to determine that. You can graph that in mechanism environment as well. But for now, I don't want to discuss more about mechanism. Just want you to see that we can be able to set. Now you can see we don't have interference after running a mechanism, and we have a minimum clearance between these two surfaces. Okay, therefore you can try to perform your own analysis, and also you can try to vary also the diameter of this part here, this diameter, such that we have maybe certain minimum clearance. You can also do that. Thank you and stay tuned for more such videos. Share, like, and comment. Bye.